These are your homework answers coming up. They are boxed on the right-hand side with the problem number beside it, so it's easy for you to see. Your objective today is the same as yesterday, except in addition to completing the square in a quadratic expression, we are now going to find the maximum or minimum value of the function from the completed square form and use it in a business application problem. A certain business is marketing its product and has collected data on sales and prices for the past few years. For example, they sold 6 one year, or the price was 6 one year, and they sold 45 of those items. Another year the price was 7, then they only sold 40. And notice how it goes down. The company determined that when it raised the selling price of the product, the number of sales went down. The cost of producing a single item is $3. So from part A, using the data the company collected in this table, determine a linear expression to represent the quantity sold. We've done this before. Do you remember when we had to have 2 points and you had to find the slope of a line given 2 points? Do you remember that? Okay, some do, some don't. And then once you find that slope, you put it into the slope-intercept form and then insert the point, one of those points, solve for the y-intercept, and then you have your equation. That's exactly what we're doing here. So this will be review for you. So first you have to pick 2 points on this table. What 2 points do you want to use? Given that the selling price is X and the quantity is indeed Q, but you could also think of it as Y. What 2 points do you want to use? Pick 2. Galleon's going to pick 2. Okay, that's 1 point, 7 and 40. What's the other point?
9? I don't know. What do you mean, which number?
Well, like this is an X and this is a Y. So 740 would be 1 point.
Oh, okay. 9 and 30.
9 and 30. So 740, 930. Okay. 740, 930. Those are our 2 points. Remember that these are in X, Y form. And you have point 1 and point 2. So that would make this X1, Y1 and X2, Y2. Does anyone remember the formula for slope given 2 points? What is it? That's right, y2 minus y1 over x2 minus x1. Fantastic. Now we have to plug in our numbers. What number is y2? 30. And we're going to take away what number? 40. On the bottom, what number is x2? 9. And we're taking away what? 7. Okay. So let's come over here. 30 minus 40 is negative 10. And 9 minus 7 is 2. So we end up with a negative 5. Does anyone remember the general form of the slope-intercept form of the equation of a line? Slope-intercept form. Do you remember what it is? All right, well, here it is. Y equals mx plus b. Do you remember which letter in that equation represents slope? It's not b. It is m, yes. M is slope. And we just found the slope to be -5. So let's replace that x with, or not x, but the m with -5. Do you remember what you have to do in order to solve for b? What must I plug in? I'll give you a hint. You have two choices of what to plug in. What variables are we going to plug in for? X and Y. So what in general are we going to plug into this equation? We will play Wheel of Fortune, speed round. I, N, P, T, point, yes. At least we got it before all letters had been placed into the puzzle. So we're going to pick a point. Are you going to choose this one or this one? It makes no difference. Pick one. 9 and 30. All right. Remember that 9 is an x value and 30 is a y value. So 30 goes in for y and 9 goes in for x. You now have to solve for b. -5 times 9 is -45. Move the -45 to the left, make it +45. So we end up with 75 equals b. Remember back up here, we had to solve for b. That's why we did all that below that. We now found it. So it is going to be y equals -5x plus 75. And that is the equation to represent the number of items sold. The answer for part A. Do you remember back in the table where it had on the left-hand side of the table it was x, and the right-hand side I said you could let that be y? What was really the variable for the right side of that table? Q. So you can also write this as Q equals -5x plus 75. And this is the one that we will use. Part B is to find an expression to represent the profit function P. Okay, well, profit function, I can tell you that the profit function P will be determined by X. X is the sale price of an item, what you're going to charge for it. But in general, without putting a bunch of variables in here, we have to understand what the profit function is to begin with. Here's the profit function, as simple as I can explain it. This pencil cost me 25 cents, but I'm going to sell it for 50 cents. What is my profit? 25 cents. So if I generated a revenue of $1, but the production cost for that pencil, what it cost me to acquire that, is 25 cents, then I subtracted 50 cents minus 25 cents to get a profit of 25 cents. So that's your production cost, or your profit function in general. But now we have to understand, what are we going to use to get revenue? So here's revenue. I'm going to break revenue down for you further. Just revenue alone. I have 5 pencils, and they are 25 cents each. If I sold 5 pencils at 25 cents each, then how much money have I generated in revenue? $1.25, right. So that came from the number of pencils times the price of that pencil. Remember, the price in this problem is determined by X. So we have X. And the number that I have is the quantity. Remember, Q is quantity in that table. And remember back here for this linear expression or equation, Q is equal to negative 5x plus 75. So come down here and do negative 5x plus 75. This is going to be the price, and this is the quantity. That's revenue. Okay, so now we have a production cost. Each one cost me 25 cents to make. Well, in the previous example, I told you I had 5 pencils and they were 25 cents each, and the revenue was $1.25. So let's change this. Each pencil cost me 10 cents. It's costing me 10 cents. And if I acquire 5 of them, then what did it cost me to have 5 pencils? 50 cents. So I would take that 50 cents away from the $1.25 in the previous example. But I came up with that production cost by having a quantity and a cost per pencil. Do you remember what the cost per item in this problem is? $3, yes, right here. The cost is $3 per item that they are selling. So we'll go back down here and put in the cost, $3, times the quantity of them, which again is going to be negative 5x plus 75. Remember, this is the cost for the company, and this is the quantity.
Mr. Skinner.
This is the answer for part B. On part C, it is at what price can they maximize their sales? Here's what we want to do first. We want to come back up here and simplify this profit function. We want to simplify that. And actually the answer for part B should be simplified. So technically we're still on part B. We have to multiply through here by x. X times negative 5x is negative 5x squared. And then x times 75 is plus 75x. And now we go over to the other side and treat this as negative 3. Negative 3 times negative 5x is plus 15x. And then negative 3 times 75 is negative 225. Simplify like terms. 75x plus 15x is 90x. Now that is technically your profit function, simplified. So now we're officially done with part B, and we can go look at part C. Look at this in general, actually this. Didn't we graph stuff like this before by finding intercepts, a vertex, a y-intercept? We just had a test over all that stuff. This opens up or down? Down. It opens down because why? It's a negative a value there on the x squared. So it's going to look something like this. And will it have a maximum or a minimum point? Maximum. A maximum point that point will have an XY value. In our case, it will have an XQ value because that's how we've set it up. And we can use that vertex, that maximum point, to determine the price at which this company should sell their item and the number of items they can expect to sell. You do not have to use x equals negative b over 2a to get the x value of the vertex and then plug it in to get the y value like we did before. What you can do is what we've been doing the last couple of days, and that is to complete the square. So group these first two together and take out your negative 5. When you divide negative 5x squared by negative 5, you're left with an x squared. When I divide 90x by negative 5, what do I get? Negative 18. So let's make that minus 18x. Leave a space, and then minus 225. What is half of 18? 9. What is 9 squared? 81. But we haven't just added 81. What we have really done is negative 5 times 81, which is what? Negative 405. So we have really done what? Yeah, we've really subtracted 405. So instead of subtracting 405 out here on this spot, I have to do the opposite, which is add 405. Now, most of the ones that we've been doing have come out to where we've added something, then we subtract on the outside. In this one, we subtracted 405, so now we have to add 405 on the outside. Now you simplify it. Negative 5 times the quantity squared of x minus half of 18, which is 9. Close the quantity. And what is negative 225 plus 405? 180. With this form, you can find the vertex. Here is the general form of this. Quantity squared of x minus h. Close the quantity plus k. Notice that in the general form, you have a minus sign. So that if you have a minus sign here, all you need is that number 9. So the x value of the vertex is 9. Notice in the general form of the formula or the expression down here, you have a plus sign. So if you have a plus sign up here, then you just need that number, 180. That is the vertex, x, y. Or in our case, it's xq. Because x represents the price for the item, and q represents the quantity. So this vertex allows us to answer the question C, which is, at what price can the company expect to maximize their sales? And that is going to be a price of $9, and from that they can expect to sell around 180.